Okay, welcome everybody. I'm Elisa. I'm working for the Amsterdam Internet Exchange, and thank you very much for introducing me. So I was working on traffic analysis on our exchange based on sFlow data, and I'm going to talk about how we implemented that, what we did, what kind of things we found out during testing and the implementation of a tool to do that on our exchange. It's going to look like that now. I'm going to say briefly a couple of things about sFlow that are important to know. I think most of you already heard about what sFlow is, but anyway, there are like 2-3 things I would like to point out that everybody knows what I'm talking about. Then about requirements and plans, what we actually wanted to do with that. Things we ran into while testing with the hardware we use, and things I found out about other vendors and hardware. Then there are a couple of software solutions to collect and analyze sFlow data. And I'm going to say why we don't use them and why we, in the end, implemented our own software to analyze that. And I have some results and pretty graphs and things to show at the end. Okay, so what is sFlow? sFlow is implemented on switches and routers. It's a standard to capture packets. The captured packets are exported via UDP datagrams to a collector, and the collector can analyze and store the data. It's pretty efficient because it's sampling, so we don't have to look into every packet, and that's why we can do that on high-speed links as we have at AMS IX. So it's a standard. A lot of vendors implemented it on the hardware. We use Foundry switches at AMS IX, so most of my testing was on Foundry hardware. Important to know about the standard is that not everything is sampled information. The standard defines two different kinds of information we can put into the datagrams. One of them are flow samples. That's what everybody's thinking about talking about sFlow. The other thing are counter samples. Counter samples pretty much replace the data you can pull from your devices via SMP. So it's like interface information on counters, errors, and stuff like that. And the flow samples basically capture the packets, so you can define an interval, like I would like to have 1 out of 8K, and you get 1 out of 8K packet headers, which you have to parse and analyze and count. Okay, so the plan, what we actually wanted to do in the first place, is to use the flow samples and make a member-to-member graphs, because so far using MRTG we have graphs of the interface. Every member at the exchange knows, okay, I'm pushing that much traffic over one interface, but he doesn't know where the traffic is going to if he doesn't have his own accounting on his side. So it was like, okay, it would be a nice service for our members to see where the traffic is actually going to. We can do that because we have a policy of 1 MAC address per member. So if we decode a packet and look at the MAC addresses, we know exactly from which member to which member it's going over a switch platform. And there's more we can look for because we get the whole packet header. So we were also interested in seeing things like the ether type of the packets going over the exchange. But as we are a layer 2 platform, we don't really want to do more than that. So we pretty much restricted ourselves not to look deeper than layer 2 information. So we don't decode or store or whatever any IP addresses or more information about the members' traffic. And the other interesting part about the counter samples that sFlow is providing was, well, we have some issues with MRTG, and MRTG is not like the, well, we were thinking about replacing MRTG with the counter samples that sFlow is providing. but I'm going to talk about MRTG issues later on. A bit more on AMS IX. So we have really high demands on performance. Currently, it's a bit more because I prepared the slides last week. So it's, I think, 280 gigabits per second right now. So if we end up with a sampling rate of 8K, 5K samples per second, the samples are packed in the UDP datagrams of like 5, 6, 7 samples per datagram. So in the end, we end up with like 700 UDP datagrams arriving at our collector and 5K samples to be parsed and analyzed. So the software we want to use, or we have to use, needs to perform and needs to handle that amount of data. So even if it's sampled information, it's still a lot of stuff coming in we have to look at. One short slide about the MRTG stuff. So it looks like the small peaks and going up and down of the graphs, of our traffic graphs. That is due to CPU load, I/O issues, and general MRTG issues the software has. And that's something we can avoid with the sFlow counter samples because we don't have to poll the devices all the time. So it's, well, better for the devices and better for in the end, our collecting server to plot the graphs out of counter samples from sFlow. And something about the sampling rate, because I did a lot of testing in our lab with generated traffic to figure out what would be the best sampling rate to go for. And, well, that's a graph showing Foundry RX8 with, we plugged in a different interface, a different amount of interfaces on one blade. On Foundry RX8, the blade CPU is used for sampling the data and for packing the UDP packets. So I was watching the CPU load on this specific blade we used to test that. So there's like 8, 12, and 16 interfaces on one blade with different amount of frames pushed over this one blade. And it looks like that. So at some point we decided to go for 8K as a sampling rate because it seems kind of safe. In the end, the highest amount of packets we used to test that is, what was it, 30, 40 million packets per second, which is pretty much the amount of packets we have on the whole AMS IX platform, so that shouldn't happen on one blade, but it was interesting to see what's going on then. So we went for like a safe way to not have any issues with the hardware in the end, and we use 8K as a sampling rate right now. That looks pretty much the same on the RX16, and it's a bit different on all the Foundry hardware because they don't have blade CPUs. They only have one CPU in the switch. So, well, but it's still using up the CPU, and it's still 8K was on like the older devices. It was still good. Some other things about hardware that are interesting is, for example, that. So sFlow samples the packets only going in one direction, which means that in the end the vendor has to decide if they sample inbound traffic or outbound traffic. And on Foundry devices it's inbound, which means that if packets are dropped inside the switch, we don't really know about that because we see like packets coming in and we don't know if they go out again on the other side. On Force 10 devices, it's exactly the other way around. So you don't know how much actually got pushed into the switch, but you know what came out of it again. In the member-to-member graphs we do, which is, for example, on the right side, we assume pretty much that everything one member pushes to the other one is also coming out on the other side. That's why we plot in and outgoing traffic in a graph. But as we can see there, it's like, well, I think it's more than a gig, and this member actually only has a gig port. So you don't, yeah. We know that somebody is trying to push 1.2 gig to this member, but it's not ending up there properly. So that's one interesting thing you can find out about hardware, different implementations of different vendors in sFlow. Another thing while I was testing the counter samples is that, so you define a fixed polling interval for the counter samples. Means, for example, every 300 seconds, because I want to plot a graph in 5 minutes. So, okay, 300 seconds should be enough to get the interface counters. So if I do that, I cannot, I don't know when the sample is actually taken. So it might be that, like, within the time frame of 300 seconds, counter number 1 is coming after 100 seconds and counter number 2 after 200. So if I would like to add up the data and make a total graph of all the counters at the end, I have different values from different times, which is, well, not really useful, because if I want to have a total graph on one certain point, I need the counter information of that time and not like 30 seconds before that. So, well, it's also an implementation question. Well, they might consider to do something like, okay, I can define that I would like to have it within 300 seconds, but at the end of a full minute or something like that. We cannot configure that on the switches, so what we decided to do in the end is, and we tested that as well a lot, to define a sampling rate, a counter polling interval of 1 second. So we're getting all the interface data every second, and basically we throw away everything we get and we only keep the last one, the orange one in the graph there. It's a bit a waste of data because we don't need it, but the hardware is dealing with that, and we, yeah, have at least the current data at the end when we want to plot the stuff. Okay, that's about hardware and findings. Software. There are a couple of tools out there to use analyze on the collector side. One is sFlow tool from Inmon. It's an open source tool, and it's pretty much for testing purposes, because it's just plotting out, it's just printing out the data to send it out, and you just see what it is. I know that some people parse the output of this tool again to then count, analyze, and do whatever with it. We couldn't do that because, well, for 5K packets per second parsed via one tool and another, that wasn't working anymore. PMACT is also C software written in C. That one is storing the data to a database. So we could choose between MySQL and Postgres to write the whole packet data down. That is, first of all, it wasn't working with 5K packets per second again. And second of all, we don't need the whole data. We don't need everything we get there, because to make member-to-member graphs, we pretty much only need MAC addresses and the packet size, and we can calculate what's going from one member to another. So that was enough. So at some point, testing all this, Inmon Traffic Sentinel is a commercial software. One can buy that. I don't know exactly how this is working. So, but some people use that as well, and it seems to work. Insanely expensive. And libsFlow is the library written by Richard Steenberg, and he presented that last time at NANOG, as far as I know. That one wasn't released yet when we started working on that, because I started working on that like a year ago, and so we tested all the software, all the free software, and decided at some point, okay, it's not doing exactly what we want, and we have to customize it anyway, and well, yeah, let's just write our own stuff, because then we have exactly what we need and exactly what we want to do. So we started writing our own software in Perl, because half of the AMS IX NOC is yeah, into Perl. First I wrote a decoding module for sFlow packets, sFlow, which is open source and available on cPan. And then we wrote a daemon around that to analyze and store the data in RD files. Another thing about databases and RD files, in the end, if you want to plot data in RD files, RD is a database already, which is great because it's throwing out old data, and you don't need to clean it up like a common database. You have to take care of deleting data again and things like that. So RD is pretty cool to, well, I put it in there and I can just leave it there and don't have to take care of it anymore. So it's a bit of a waste to put data into a database first and then into RD again. So we decided to just collect it, cache it somehow, and throw it into RD, and it's done. And we have to like look up stuff in our databases, member databases, to have like names and everything we need, which is also in Perl everything. We have libraries to access our database, so it was easy to integrate into the whole AMS IX environment. The software is also used by a couple of other people by now. The Vienna Internet Exchange implemented their own daemon around this sFlow module, and we've been in contact a lot, and they pretty much did the same thing, like plotting member-to-member graphs and stuff. So performance of this Perl software is, well, the decoding is obviously slower in Perl than we could have it in C, but it's still okay. The server can handle it, and to have it better integrated into our environment, I think it's okay to have like, well, some CPU load. I was thinking about maybe making a part of it in C and have like a Perl thing around that, but that's something to think about. But it's really like, I think at AMS IX it's pretty much like really a lot of data we have to parse and store, and everybody else who has less shouldn't have any issues with CPU on that. So what we do with the member-to-member information is we cache the data in the daemon running, and every 5 minutes we write it down to RD files. We have about 450 members right now, 450 ports. So that ends up in, well, a maximum of 200K RD files, which is a lot. And but from what we see right now, conversations are peering going on between the members. We're plotting 50,000 graphs, and the server is doing that in like a couple of seconds. So that is still working. Okay, and some results on accuracy. So it's well, sFlow is statistics because we don't see everything, and we couldn't. So what I was trying is to get all the data together and to compare it with the polled MRTG graphs to see if it's actually kind of accurate. And it is, but because it's statistics, so it's the smaller the amount of a certain type of data you're looking for is, the bigger the error is in the end. So if we look for like a small Mbit port from a 10 Mbit port from a member, and he's not pushing a lot of traffic, the error is getting bigger in the end. But it's kind of okay because it's not something people depend on, and it's not values that they really, well, have to have every second bit of it. So for like having an idea of who you're peering with and what the amount of peerings between the members is, it's okay. Around that, in the end, after the software was running, we collected data for a couple of months. I wrote a web interface around that just to give an impression. It looks a bit like that, and it's calculating the stuff up front, so we have like a top 10 or top something list the members can look at and see where the traffic is going to. Also, we have tools now for our own usage, like overviews like that, to see like the top something peerings between our members and things like that. Always funny to present is the IPv6 graphs we have, because we were interested in seeing how much IPv6 traffic is actually going over the AMS IX platform. It was a bit more in the beginning, I think, then some member forgot to turn on IPv6 routing again after they migrated their port, and now it's less. But yeah. So what people do with that now is, well, they use it. I heard from a couple of members that they're actually looking at it, and they use it for like traffic engineering. And one example is that somebody told me he was about to set up a private peering with somebody else, and after he looked at a 1 gig connection, and after he looked at sFlow, he was like, oh, well, but we're pushing 1.2 gig there, so it doesn't really make a lot of sense. So they stayed. Obviously, a couple of members see that they do enough traffic with somebody else to actually set up a private peering, so they leave us, well, yeah. But it is useful. It is also useful for us to see what's going on. Well, if somebody is sending traffic in some weird way, and we look at it a lot. Another example is we were interested to see how much of a member's traffic is actually going over the core, because we have like a core and a lot of edge switches connected to that, and we wanted to shift around things a bit, and so we were looking at sFlow to see, okay, that member is not pushing a lot over there, so we can change our architecture based on that. What I'm busy with right now is to work on a way of notifications, to have like emails or notifications about, hey, something happened here or something is going on there, because right now we just have to look at the graphs to figure out what's going on right now. So we keep working on that, and well, we have some good experience with it so far, and that's it. Questions? Nothing.
There's no other questions. I have one. You showed an sFlow-based traffic engineering matrix. It's quite common practice at internet exchanges to generate a peering matrix from data in the routing registries. Mm-hmm. Have you considered comparing the two for consistency?
We didn't. No, we haven't actually. But the Vienna Internet Exchange, they make a peering matrix with sFlow data, and they actually published it. But a lot of members were not really happy about it. So, well, they have an option to opt out there and not be in the matrix, but then it's not really useful anymore when you have not everybody in. So we're not. That is only for our own usage, and we don't publish that one.
Okay, thanks very much.
Thank you.